So এখান থেকে next জিনিসটা আমি চাচ্ছি to talk about is basically the nuclear structure. ঠিক আছে? So এটা নিয়ে আমরা একটু কথা বলি. So আমরা first যেটা মনে করছিলাম was that the nucleus consisted of just protons and neutrons. Whoops. আমরা first মনে করছিলাম the nucleus consisted of just protons and neutrons. This was after alpha scattering experiment proved the existence of the nucleus. What else did we had other scientists like Chadwick and stuff. They said যে না nucleus এর মধ্যে খালি proton না সাথে অন্য particle আছে. What we found out যে হ্যাঁ neutrons আছে. That's the only explanation behind the mass of the nucleus and stuff like that. So এরকম করে we started to see যে actually এখানে you had a mixture of positive charges and neutral charges. So তখন we had this long period of time যখন we considered that the nucleus, the fundamental particles of the universe are actually neutrons, protons and electrons. ঠিক আছে? So this was more or less alright, সমস্যা ছিল না. But there were a couple of theories which clashed with this, and there were a couple of reasons why they were clashing. One of the reasons আমাদের এই theoryটা didn't work nicely was the beta decay phenomenon. Beta decay তে কি হয় মনে আছে তোমাদের? ওগুলো শিখছিলাম? And even if you don't remember, let's do a quick review. Two electrons. I don't know. তোমার কি হইতো? A neutron used to decay into a proton. And in the process, it would release particles. একটা particle was an electron, and another particle is known as an anti-electron neutrino. ঠিক আছে? বুঝছো জিনিসটা? Doesn't really matter how you write it. ঠিক আছে? But তোমার anti-electron neutrino ছিল. So এখন এখানে why does this violate this concept? কে বলতে পারবা? Why is this being violated because of this? আচ্ছা এটা একটা জিনিস যে we got this other particle, but ধরো এটা massless chargeless particle, so we ignored its existence. এটা ছাড়াও সমস্যা হচ্ছিল. So what? Charge to conserve হলো আগে neutral পরেও neutral, proton plus minus, right? Can anyone see the problem here? More or less, yeah, that's the point. The point is that if a neutron is a fundamental particle, you can't change it. So if you're playing with Lego, if you're playing with Lego and if you have a Lego block, and if you can change that block type, like say Lego block ছিল না যে চারটা এরকম চারটা এরকম, if you could change that, তাহলে মানে কি? And মানে this can be broken into smaller bits. Do you get it? So similarly, মানে এটা ধরো বা যে চিকন কয়েকটা থাকে না যে খুলতে যে আঙ্গুল ভেঙে যায়, তো তিনটা পিস একসাথে থাকে. So if you could change the color sequence, ঠিক আছে? এর মানে কি? এর মানে হইতেছে যে this is not the fundamental particle. These three pieces are the fundamental particles. Or the sequence change করতে পারো. So that means if you could change a neutron into a proton, that means there's something inside a neutron which can be broken down and be converted into a proton. So beta minus decay actually started to violate this when we started realizing that beta decay হচ্ছিল from the nucleus. এটা তো সবার মনে আছে. Beta decay যখন হয়, the electron is not released from the orbitals, it's released actually from within the nucleus. So তারপর what we did is we started hitting, আমরা যেরকম alpha scattering করছিলাম, তারপর what we did we started hitting particles with higher and higher energy. ঠিক আছে? nuclei hit করা শুরু করছি আমরা, তারপরে protons hit করা শুরু করছি, neutrons hit করছি, মানে charge up করে যা চেষ্টা করা সম্ভব ছিল hit করে we tried breaking it apart. And eventually, fairly recently, we figured out that neutrons can be broken down, protons can be broken down. আর ভাঙার সময় lots of different bits and pieces come out, but usually these are the most stable, neutrons and protons. Okay, so what we saw was neutrons were actually made of, neutrons and protons, we call them nucleons, right? What's up? Nucleons, these are a specific type of nucleons. These are also called hadrons. Okay, so hadron বলা হয়. Hadrons এর মধ্যে দুই রকমের আছে, we'll talk about that একটু পরে. Proton না. So neutrons and protons are. So what we saw was neutrons were actually made of three smaller particles. And protons also similarly were made of three smaller particles. These particles, we name them quarks. We call them quarks. Does this make sense? So hadrons are basically quark combinations. Hadron আছে দুই ধরনের. একটু just detail বলতেছি এখানে. You can have baryons, which are basically neutrons, protons, which are basically three quark combinations. And you can have mesons. Mesons are basically a quark and an anti-quark combination. Does this make sense? But basically, these are quark combinations. So আমরা বের করছি যে fundamental particle quark ছিল. However, electron কে আর ভাঙা যেত না. At least till now we know that electrons can't be broken down any further. Similarly, electron neutrinos এগুলো ভাঙা যেত না. So what we came up with was basically there are 6 fundamental quarks and there are 6 fundamental leptons. Take it. So what were the 6 fundamental quarks? They were up, down, charm, top, bottom, strange, and charm. And electron কি কি ছিল? Electron neutrino. Take it. And that's not a particle, that's an antiparticle. তারপরে we had muon, ঠিক আছে? Muon neutrino.
So leptonটা কি?
Lepton both the same. And then we had tau and tau neutrino. Okay, so we'll talk about those for it. So basically, therefore, we have again a total of 12 fundamental particles. So our current understanding is that everything which is matter is made of these particles. 6 quarks and 6 leptons. So quarks মধ্যে charge আছে, lepton মধ্যে charge আছে. ওরা কিন্তু তোমার they're not the usual charge that we see in protons and electrons. মানে electron টা yes, these are -1, 0 ওইরকম. Quarks এর ক্ষেত্রে আমরা যেটা দেখছি, the charge is actually a fraction of 1. For example, up এর charge হইতেছে আমরা ধরেই +2/3. আর down এর charge আমরা ধরি হইতেছে -1/3. বাকিগুলোর charge আছে, but we need to focus on these two. So now, how does any of this make sense? Now, if you go back to a proton charge is +1. Quark combination অনুযায়ী, if it's a baryon, it's up, up, down. So up is +2/3. Arekta up is another +2/3. Minus or 1/3, which is basically what? 3/3, which is basically 1 + 1. Do you get it?
Yeah.
This is how we get charge. Our neutron হইতেছে down, down, up. So তখন কি হয়? তোমার -1/3. Everyone's dropping everything today. -1/3 plus 2/3. So eta তুমি যদি ইয়ে করো, if you equate this, you get 0, which explains a neutron being neutral. বুঝছো জিনিসটা? We're going a little bit backwards with this, but basically that's how we explain all of this. Does this make sense? There's a very fundamental difference between quarks and leptons. কারণ দুইটারও কিন্তু mass কম বেশি আছে, charge আছে না আছে, এরকমই আছে, particle matter সবই ঠিক আছে. The fundamental difference between the two is how they interact with strong nuclear forces. Do you guys remember the fundamental types of forces? কি কি ছিল? Yeah, there are 4 fundamental types of forces. কি কি বলতে পারবা? Come on. What are the 4 fundamental forces?
4 fundamental forces.
Yes.
Strong nuclear.
Yeah, that's one. Strong nuclear. মাত্র বললাম.
Weak nuclear.
Smart. Very smart. I'm being sarcastic. Weak nuclear. তারপরে আরো দুইটা আছে. Come on.
I remember.
No, you don't. If you remember, then বলে দিতে. Gravitational.
Oh, right.
Yeah, sure. Or electromagnetic. Electromagnetic মধ্যে you have electrostatic, magnetic, all of those. So basically তুমি যে friction গুলো, air resistance গুলো, এগুলো সব কিন্তু electromagnetic এর মধ্যে পড়ে. Whenever you have masses attracting each other, basically weight and everything, that's gravitational. এই দুটোর মধ্যে হচ্ছে all the forces that you know of. They can be simplified into either gravitational or electromagnetic forces. And strong nuclear forces is the forces which interact with quarks but do not interact with leptons. That's why orbitaler যে আমাদের যে electron গুলো আছে, they never get stuck in the nucleus. Never বলা ঠিক না, but মানে usually. That's because strong nuclear forces don't interact with them. যদিও they're oppositely charged from the protons, you might think that they're supposed to collapse. But because of a number of reasons, including the fact that they don't interact with strong nuclear forces, that doesn't happen. What's the জিনিসটা? So that's how we define the difference between quarks and leptons. Quarks interact with strong nuclear forces, that's why they get stuck together, and that's why we actually have quarks only in combinations, because or a combination chara, they don't exist. Do you get it? Either they exist in combinations of 3 quarks or they exist in combinations of a quark antiquark. Is this clear to everyone? Guys? Very well. So this is the basic concept of fundamental matter. So leptons are quarks. Now, there's this other thing that I would like to tell you guys about. All the particles that we have, like quarks and leptons, these are all particles. These are all matter. So quarks আছে কয়টা বললাম? 6টা. Lepton আছে কয়টা? 6টা. So there should be an equal number of antiparticles. ঠিক আছে, antiparticles মানে হইতেছে যে if you have 6 quarks then you should have 6 antiquarks. So এখন খেয়াল করো, antiquarks a concept it might be easy to understand. We have basically a concept where we have equal matter and antimatter. ঠিক আছে, so if I was to say, if I write a a quark combination, it would be, say, let's write down a quark combination for a proton, which would be up down. up down জিনিসটা কি, তোমাদেরকে সাম জিজ্ঞেস করবে, ক্যালকুলেট করতে বলতে পারে, এরকম জিনিস জিজ্ঞেস করতে পারে, যেটা রেজাল্ট আসবে হইতেছে আপ ডাউন তুমি পাবা, বুঝছো, মানে খাটাখাটি করে তুমি বের করবে যে প্রোটন হইতেছে আপ ডাউন। বাট ইফ ইউ নো দিস আপ ডাউন, then it becomes really easy. তখন you know what the result is supposed to be. They don't expect you to know this, but it gives you a small advantage generally. আর এটা তো আর অত কোনো আমরি জিনিস না, জানা রাখলে তো সমস্যা না। So if we were to draw if we were to write the anti-quark combination of a proton, basically, no, wrong. Down up would be a neutron. Up down anti would be anti-up. The upre tanta dewa, the bar represents antiparticles. So anti-up, anti-up, anti-down. So it's not the same as particles. If you said upper anti is down, this is not true. Because upper charge is a plus 2/3. This is one of the reasons. Down charge is a minus 1/3. So এখানে we can't do that. এখানে কি করতে হবে? এখানে এটা হইতেছে plus 2/3, এটা হইতেছে আরেকটা plus 2/3, আর এটা হইতেছে minus 1/3, ওই যে আগের জিনিসটা। Anti down গিয়ে যেটা হয়ে যাবে, this will become minus 2/3. Do you see what's going on? এটা পুরো চার্জটা উল্টে যায়, plus 1/3, পুরো চার্জটা উল্টে যায়। So যেটা কারণে এটার ওভারঅল চার্জ আসবে -1 আর এটার ওভারঅল চার্জ আসবে +1. Is this making sense to everyone? So this is how particles and antiparticles are. এখান থেকে তোমাদের যে মানে পার্টিকেল অ্যান্টিপার্টিকেল গুলোর সম্বন্ধে you have to be aware of is basically anti-leptons এর মধ্যে you can have anti-electrons, ঠিক আছে, which is basically a positively charged electron, which can also be called a positron, ঠিক আছে, এর নাম দেওয়া হয়েছে আর কি, is the same as an electron. Positron হইতেছে a charge of +1. আর এরকম you can also have the neutrinos, যেটা বললাম, আর নিউট্রিনোর অ্যান্টিপার্টিকেল গুলোকে বলা হয় antineutrinos, which is very simple. Is this clear to everyone? Really simple, jhamala temon kichu ekta nai. So these are the fundamental types of particles, and also we've talked about how to combine them. Is this clear? Alright, if you go back to the syllabus now, basically we've talked about these things. Not fundamental particles consist of quarks, quark models of up-down strange. 18 ta tomader jantei hobe je 3 quark ase up-down strange, but actually ase 6 ta, right? Up, down, top, bottom, strange and charm. And the respective antiquarks. Antiquark to buchcho. Upper anti হইতেছে anti-up. Downer anti হইতেছে anti-down. Stranger anti হইতেছে anti-strange. Yeah, very simple. Describe protons and neutrons in terms of a simple quark model. ঠিক আছে, যেটা বললাম আমরা, ঠিক আছে, এটা এর জন্য up down up টা জানা থাকলে ভালো. So basically 3 quark combinations.